Hi, this is Gordon Parker from Michigan Tech. In this video we're going to cover a very powerful command for both Simulink and SimMechanics called set_param. In short, it lets you change model parameters using the command line, or even better yet, using .m script files. This is instead of clicking around in the model's graphical interface. This is a huge advantage since you can manage multiple .m files, each with a different set of parameters which define the scenario you want to run. Now I'll call these setup files, but you may want to call them something more meaningful to you, such as scenario files or configuration files, etc. But here's the sort of things you can do with this scheme. In the previous two videos, we looked at three different scenarios of a vibrating mass. It was on a horizontal surface, hanging from the ceiling, and then also on an inclined plane. Now recall that we did this simply by changing the rigid transform rotation angle that was attached to the prismatic joint that represented our spring and damper. If you actually wanted to simulate these three different configurations, you could make three different model files, just like I did in the videos 1 and 2. But a better approach would be to have one model file whose configuration is changed using three different .m files. The reason this is better is that once you have a model file set up properly, it's best not to fool with it, as they're very easy to accidentally change with a quick finger click someplace. One day it works fine, you click around in the model file to change the parameters, and suddenly it no longer works as you expected. Pretty common situation, at least for me. Now having said all this, there are many ways to implement this approach. It isn't necessary to use the beautiful set_param command. However, if we use the set_param command, then we can maintain visibility of our numerical settings on the front face of the model via the block annotations, which, as you've figured out by now, I'm pretty fond of. Finally, we'll be exploring this for SimMechanics, but it works equally well in any Simulink model, and it's much more powerful than what I'll show here. We're only going to scratch the surface of this command, and I highly recommend you dig into it more in the MATLAB help and also online. Okay, so here we are in Simulink, and we're starting to accumulate quite a few files. I'm going to work with the hanging vibrating mass file, and here it is. This is the one that we used and developed in video number 2. And the first thing we should do is just make sure that it works as expected. Now what we're going to do later is modify this gravity setting and also the Z0, the initial configuration of the block. So let's update the diagram. That brings up the Explorer, turn on the frames, and then let's use the pan tool just to scoot things around a little bit, shrink it down, and slide it down a little bit. Let's see, we need to see our frame. There it is. There's the top frame, right? Because in this case it's hanging from the ceiling. And let's see, we could just run it. There it is, vibrating. The initial position of the block was 18.5 centimeters, which was different than the static equilibrium configuration that we developed in video number 2. Great, so that works. Let's go ahead and give it a new name. And since it can be pretty much anything we want, by the time we're done with this little session, let's just call it any vibrating mass. Now, as I mentioned just a moment ago, we're going to be modifying this using a script file. So I'll give it this rather long name, any vibrating mass setup.m, and there it is. And let's just add a couple standard commands to clean things up. Clean vars will get rid of anything in the workspace, and close all just closes any figure files that you have open or figure windows. We don't have any, but it's a nice thing to do. And here's where we will set some parameters, and we're just going to, for now, set the gravity vector and also the initial position of the mass. So there's our gravity, and notice I've changed it just a little bit from -10 to -9.81. That way we'll be able to see that something's actually changed from what we had before. And here's the initial position of the block, Z0, and just give it some kind of value here. It's always good to put in comments with units. Very good habit to get into. And so now what we're going to do is look at two different ways to modify the model file using this .m file. The first way is to simply open up each one of these blocks, and where we had numerical values, like this little vector 0, 0, negative 10, I'll just give it the variable that we defined in the .m file, so in this case, grav. And in the prismatic joint, same kind of thing. We'll go in here where we have the initial position of the brick, and we'll just say that's Z0. And as long as those quantities are defined in the workspace, it'll work great. Update the diagram, and boom, we get some errors. And that's because they're not defined in the workspace. So it doesn't know where to find grav nor Z0. And that's because we didn't run this file. So let's run it. Aha, so now grav and Z0 are in the workspace. We can update the diagram, and hopefully no errors. Good. And we should bring up our Model Explorer again. Here it is. Move things around a bit so we can, there we go. Simulate, and it vibrates. So you can see that what we put into the .m file got into the workspace and then was accessible by the model. And just to see this more completely, we'll change the initial position of the block radically. I've run it so that's updated in the workspace, as you can see here. You can update the diagram. And so this initial position is really scrunched up, so we're compressing the spring quite a bit initially. Run it, and there it goes. Drops down and vibrates like mad. Great. So that's one way to do it, but if you look at the front face of the model, it's not very satisfying because you don't really see what's going on. You can see G and you can see Z0. So, yeah, you can see that the variables that you defined in the .m file made it in. But let's take this one step more using the set_param command. Now the thing with set_param, it takes 3 arguments notionally, and they all have to be strings. Now the first argument tells set_param which model it's using and which block. So here we have any vibrating mass and the spring 1. We'll go ahead and change that Z0 quantity. The second argument it needs the parameter that you want to change, and I don't know what that is right now, so I'm just going to leave it as a couple question marks, and I'll show you a way to figure out what the parameters are. And then we have to give it a value, Z0. Now that would never run, right? I have to find out what the parameter name is, and so we go into our old friend, the block annotation. This gives us the keys to the castle in a sense, all the different parameters that we can change. And the one that we want to change is right here. So I'm just going to highlight that so I don't have to type it and misspell it, etc. Copy it, and I'll just paste it right into where those question marks are. But again, as a string. Now, this still wouldn't run because here I have Z0, but Z0 up above is not a string. So I need to change this numeric value into a string. So I'll just put single quotes around it. There we go. So we can run this, and you can see in the workspace, and now have Z0. And look at that. That value has made it into the simulation, into the model, and we can see it on the front face. I can change it. You can see it update automatically when we run the .m file. We can run it here, and of course it knows exactly what to do and vibrates accordingly. So now let's go ahead and do the same thing for the gravity vector. So I'm just going to copy this and then paste it down here, and then change a couple things. I have to give it the right block name, mechanism configuration. Luckily it's a string, so I don't have to worry about the spaces in that name. And I'll have to determine what the name of that property is. So I go into the blocks, I right click on it, go into its properties, and then the block annotation, and there it is, this gravity vector string. Copy that. Because if you're really into this, you probably memorize all these quantities and you just type them in, but I guess I'm not to that point yet. So there we go. So we've got the gravity vector in there, and now I have to change this array into a string. So I put single quotes around it, and change this z0 to grav, the name of that variable. Save it, run it, boom. Now they're both in the workspace, and you can see that I now have this numeric value sitting on the front face of the model. Update the diagram. And there we go. Same old vibration. That's great. So now let's do one more thing. Remember, we can simulate any configuration we want, hanging, inclined plane, horizontal surface, simply by changing the angle of that rigid transform, the angle that the prismatic joint makes with the world frame. So let's define 3 different cases. For the hanging case, we needed an angle of 180, and for horizontal, we needed the rotation angle to be 90 degrees, and for the inclined plane, it depends what your incline angle is, but for the case that we looked at in video number 2, it was a 30-degree incline, so 30 plus 90 is 120 degrees for that incline. Add in some comments. And now we just have to add one more set param command so that we can manipulate the parameter of that rigid transform block. Same old game, just right click on the block, go to properties, block annotation, and grab that token name, that rotation angle token. There it is. Just wanted to keep track of it. I'm going to copy and paste this whole command down here, and then jiggle things around a bit so that we can manipulate that parameter. So let's see, we'll put this into the parameter name spot for the call right there, and I have to give it the correct block name, which is rigid transform, and finally the value that we want it to be. And here we can just say inclined or horizontal or vertical or hanging, etc. So here it is for inclined. Update the diagram. Let's take a look at that Explorer, and there it is. There's our inclined example. And we can run it, and sure enough, it does exactly what we expected. So now we have one model file that can do any of those 3 cases that we looked at in video 1 and 2. And we can still see which case we're running by looking at the front face of the model. Just to prove that, let's do one more case. There's the horizontal. Fantastic. So that's about it. A quick demonstration of how you can manipulate and manage your models using script files and this beautiful set_param command. Super powerful, and I highly recommend that you explore all of the cool things it can do using the MATLAB help and also other online resources. I hope you enjoy this set_param as much as I do. And again, this is Gordon Parker from Michigan Tech, and thanks for watching.